Let's step through this. It looks like we're doing a pretty good job on this quadratic formula. First thing you got to know how to do is use the quadratic formula, and that is, got to have it memorized. Now, some of us are using all over 2a, and then the other form that I showed you the other day, I'm still going to push for this. I'm going to keep lobbying that you use this form of the quadratic formula because it resolves some of these issues of distributing the division later. But if you use this, then you're going to have to know how to distribute your division. They're both equivalent, you just got to know how to finish it. Going back to this one, what is the value of b in our equation? I should have had that equal to 0. So negative 14. So we still need our negative sign. So equals a negative, then a negative 14, plus or minus, square root of. I'm pretty pleased. I don't think I saw anybody mess this up in this class. Every other class we've messed this up. When you square a negative, you always have to get a positive. So I got to put that in parentheses. If I'm going to do this on the calculator, which I see a lot of people doing, they're typing their calculator negative 14 squared. You know what it gives them? Negative 196. And they use it. We ought to be a little bit more mathy than that. When you square, you have to get a. So why would we accept a negative 196 in there? And I'm thankful. I don't think I saw anybody here do that I watched. Okay, it did happen to you. So you just got to be careful. Then minus a 4 times a, which is and c, which is 58. All over 2a. So I'm going to use that form, and that's 2 times 1. So when you got two negatives, it makes it a positive. So you got 14 plus or minus the square root of. We just got done talking about squaring that. It's 196. And then this is the second stickiest spot in the quadratic formula I find people messing up. This sign here, in between the first number and second number. If there's only one negative sign in this whole expression back here, then it will always stay negative. Because you're taking a negative times a positive times a positive. Anytime there's 2 or an even number, then it's going to be plus. Then you'd have negative negative, which is positive, times another positive. It stays positive. If there are 3 negatives, then it will stay negative. So even number of negative signs is always going to be plus, and odd is always minus. Anyway, we kind of have some problems. Is this 232? Yes? Okay, all over 2. Okay, then we have 14 plus or minus. And this is the square root of, and it was a negative 36, all over 2. It's 14 plus or minus. Now this is the new information. When you take the square root of a negative, it's always going to be I in it. So the square root of a negative 1 is defined to be I, but the square root of 36 is 6. So 6I all over 2. Okay, now here's where this last little piece you got to get right. Both of these numbers are being divided by 2. If you use your rules of fractions, you can rewrite this equivalently. 14 over 2 plus or minus 6I over 2. Which if you go back to this other form I was talking about, you would automatically have it set that way if you wrote it like this. So if you're struggling with this concept of distributing the division, just start with it like that. But we should have ended up with 7 plus or minus 3I. How many answers does this represent? This is 2 complex solutions. I'm going to throw out a myth buster here because I hope I don't get it, but in the past I've gotten these answers. 10I, 4I. Okay, now if I'm getting those answers, what is this person doing that's incorrect? Yeah. Adding unlike terms. These have I's in them, these don't. If they don't have I's in them, they're not the same. So don't do that. Okay? When you get down to this form, you're done. That's your solution. Alright, so next thing we got to work on is something called the discriminant. Okay, we're going to work on discriminant and factoring today, and then the rest of the time you got to work on your homework. It's not going to take us very long. It's the discriminant, the word in red up here. You got to know it by name. You got to know what it's indicating. What does the discriminant refer to? Well, here's what we use it for. The discriminant determines the type and the number of solutions we have from a quadratic equation. If we solve a quadratic equation, we can use this never fail method right here. It's called the quadratic formula. This solves every single one of our quadratic equations every time. It's one of our methods we can use. Now, what part of that quadratic formula determines the nature of the solutions? And by nature, I mean the kinds of solutions. Heard parts of it. So, one of the problems with the program I was using, it doesn't put the whole radical there, but let's determine what kinds of solutions we have. And that's why I've highlighted it down here. This b squared minus 4ac is the entire thing that determines, it discriminates, it tells us what kind of solutions we have. The rest of this formula, I don't need for that. Just take it out. I don't need it. All I need is just this part here to tell me what kind of solutions. Now, why is it just that part that's really telling me the kinds of solutions we have? Say it a little louder, can you hear me? Why do we have to get a whole new set of numbers?
Because it was negative.
Add on, piggyback off that. Because it was negative. What? That's pretty incomplete.
You can't square negative.
You see the square root sign?
Yeah.
If you square root a negative number, does it tell you what kind of answers you're going to have?
Yeah.
What if you take the square root of a negative? As soon as I say you're taking the square root of a negative, what kind of solutions are you going to get? Something I, and they're called? You're guaranteed two complex solutions. What if you take the square root of a positive? What kind of numbers were they? Okay, part of this story is two real solutions. I think I got this Venn diagram here. If they're not complex, then they had to be real. Every number that's real is a part of the complex solutions. The only time we get out here in the complex is when we take the square root of a negative. So the only time we get into complex solutions is when we take the square root of a negative. Otherwise, if we're taking the square root of a positive, it's got to be real. Okay, so look at that Venn diagram. But there's a little bit more to this story than what we've encountered so far. What's in between? If you look at the number line, you got negative numbers over here, you got positive numbers over here, but what's right smack dab in the middle? Is 0 positive or negative? It's neutral, it's neither. So what happens when you take the square root of 0? Well, it's 0, but I'm asking you what type of solutions. Remember, the discriminant is supposed to be telling us what kinds of solutions and how many. Well, let's track this back. Where's your radical sign? Radical sign on this is right in here. What if b squared minus 4ac is 0? What's the square root of 0? 0. Then this whole thing right here is nothing. It's 0. So you've got negative b plus or minus 0 all over 2 times a. Well, what's negative b plus or minus a 0 going to do? Adding 0, subtracting 0. Is it going to do anything to it? No. So all we get is negative b over 2a. How many solutions does this represent? 1. Did we take the square root of a negative? No, the square root was gone after you took the square root of 0. So if you have the square root of 0, how many solutions do you have? 1, and what kind? Real solution. That's what we've got to know. Do you understand why it's working this way? If you haven't gone through the thought process saying, why is that working that way, then you didn't do enough today. If you know why, this is going to be easy. This is going to be on your assessment. I don't need, here's what I'm going to get from a lot of people. I'm going to tell you what part of the quadratic formula tells me what kind of solutions I get. And here's what they write down. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Is this really what's telling me the kinds of solutions? No. And I'll also get people to go square root of b squared minus 4ac. Is that what I need? No. What do I need? Just this. That's the discriminant. Because what does it do? Tells you whether it's negative, positive, or zero. Okay, now I'm going to come back and I'm going to address this in one other way. Sometimes, and I think on the quiz, this is how I have it written. What if b squared minus 4ac is greater than 0? If b squared minus 4ac is greater than 0, then you have two real solutions. If b squared minus 4ac was less than 0, then what can you guarantee about your solutions? Two complex solutions. And the only other option is if b squared minus 4ac is what? And if it's equal to 0, then you're guaranteed one real solution. Nothing real difficult about this, it's just some terminology. And it's just another part of this mathematics that we're looking at, is trying to figure out what kind of solutions and what's the fastest and easiest way to figure out what kind we have. That's where it is. All right, one more push here, and then we got number 6 to do. The other thing I need you to be able to do, I got to grab my notebook here, is solve by factoring. Now this is definitely not a new skill, just like the quadratic formula is not a new skill, but we might have to brush up on it a bit. So if I go x squared plus 10x plus 24 equals 0. Now the directions are going to change from problem to problem on your quiz. Some are going to say solve by putting it in vertex form and then find solutions. Some will say use the quadratic formula to solve. But this set of directions will say solve by factoring. So we're going to solve this by factoring. Okay, so if you're going to factor, trinomials will have to factor into what? Two binomials. So that's just a little, I don't know what it is. It sticks in my head, but trinomials factor to binomials. Tries factor to bis. Gets me set up. The other thing I need you to remember is this is an extension of FOIL. When you factor, you should be thinking of foiling. They're very closely related. Now, in the first spot in this, what is the only things I can put in that first location to get an x squared? So we're guaranteed that this is x and that is x. Now, on this sign back here is positive. What does it tell you about your signs in your binomials? They're both the same, and in this case, they're both positive. You're going to have to reference back in here. They're the same, they're both positive, so plus plus. Now, what are things I can multiply together to get 24? And I got to keep in mind, I want to add them to get 10. So 4 and 6. We there? So what are the solutions? Okay, then now that links in what we just got done doing with those polynomial functions, -4, -6. Now there's another variety here that seems to throw people off their groove here, and this is the variety. 2x squared minus 3x minus 5. It's still solving by factoring. Now people freak out when you put a number in front. This is not going to derail us because it's not really that hard. Just because this isn't a 1 doesn't mean it doesn't factor. Still working with your FOIL. Trinomials factor into two binomials. You just go through the same type of thinking. What do I need to multiply together to get a 2? It's got to be a 2 and a 1. There's no other choices, so it's going to be 2x and x. Whether you go x and 2x in those positions doesn't make any difference, but we're guaranteed that this is right. Now what does this sign tell me about the signs in here? They're going to be opposites, so I don't know which one is right, but I'm going to start off with putting a plus and a minus. I may have to come back and change them. I'm going to test it. What are the only factors of 5? It's got to be a 5 and a 1. Now that means I got to place the 5 and the 1 in the right position. So I'm going to kind of put it like this first, and you're going to tell me if that's right or wrong.
Right.
How do I know if it's right or wrong? What do I have to test? What has to add up to 3? What's the other part of this that we oftentimes don't do?
Multiply the 2 and 1. Oi.
The oi. Go back and do your outermost 2 and do your innermost 2. That's a negative 10x. This is a positive 1x. If you collect those, does it give you your negative 3?
No.
No. So that tells you in this form it's not right. So what can you possibly change? Switch them around. And I'm referring to the 1 and the 5. So the 5 goes there, the 1 goes here. Now is this right?
Let's see. Yay.
Do your outside ones, that's only 2x. Do the inside ones, that is 5x. That was a negative 2x. Okay. Now this is giving you the correct number because 5x minus 2x is 3x, but we need a negative. So now you simply switch the signs. So this becomes plus, and this one here becomes negative 5. Okay, I'm not going to do any more examples of this because it's an old skill, but I did want to review it, bring it back in your head. Then, what are the solutions? This is the part that I'm worried about because that's a newer skill. We just got done doing that in our last part of our polynomials. If this is the factor, then what's the solution? 5 halves. Like to stay in practice if you can. What's the solution to this one? Negative 1. Repeat that. Yep. Take your 2x minus 5, set it equal to 0, and solve it. So it's 5 divided by 2. Okay? For your quiz, which is coming down the pike probably Tuesday, you have to solve by factoring. You have to solve by the quadratic formula. You have to solve by putting things in vertex form. Monday I'll have a review sheet for you to go over and you can work on that. It's a quiz over the last 2 rows we've been doing, and I just described to you what that was. When you get the test, when you get the whole thing, now you got the whole polynomial stuff. 3rd degree, 4th degrees, quartics, cubics, number of zeros, number of turning points. Okay, I got one departing thing here where I don't know where it went. There it is. No, that's not it. Oh yeah, this was right. I got it. Before you go on your homework assignment, do this problem and show me what your answers are. You have 4 problems to do in class. Show me what your answers are. Again, here's the directions. Use your quadratic formula. Find all the solutions. Every single one of these is going to be complex, so you're going to have to use your work with square roots and negatives. When you get done with that, then go do that homework that's due for Monday. Page 355. Yes. It is eligible for minor check.